When you type git push and press enter, your code instantly accelerates away from your local machine, firing out through a terminal into the network. This diagram maps the standard CI/CD pipeline, where security checks are run on a remote server. The system scans the incoming data, but it only flags errors after the code has already crossed the boundary into the cloud. If that incoming data contains an exposed API key or a database password, that post-push delay is a massive vulnerability. Git repositories track history. Once a secret hits the remote ledger, deleting it in a subsequent commit doesn't erase it. The credential is compromised. To actually protect a codebase, the security check has to happen right on the edge of your terminal, intervening in the milliseconds before the network request actually executes. Prepush-Guardian operates in that exact gap. It is a locally installed, multi-layered checkpoint that intercepts the staging area on your computer. By the time a leaked credential reaches a remote server, you are already doing damage control. Stopping it from ever leaving your hard drive is the only way to guarantee it stays private. When you initiate a push, your staged files first enter an abstract syntax tree, or AST, scanner. This parses your code to understand its structural logic, rather than just reading it as flat text. This animation illustrates the baseline scan. The system checks your code against 20 known vulnerability signatures. If it detects the specific formatting of an AWS key, a GitHub personal access token, or a database URL containing credentials, it rejects the push immediately. But developers routinely generate custom API tokens or internal passwords that lack a standard recognizable footprint. Shannon entropy measures text randomness. The top smooth line maps a standard English word. The bottom line tracks a chaotic randomized string, plotting a massive entropy spike. If assigned to a variable named key, it triggers an instant hard block. A reliable security perimeter has to account for unpredictable human error, catching the custom, undocumented strings that easily bypass basic pattern matching. Securing your credentials covers the privacy of your codebase, but pushing safe code that actively breaks your existing application is its own kind of failure. To handle this, the code enters the second layer of the gauntlet, a local PyTest validation. The tool runs your test suite locally, and if overall code coverage drops below 50%, it kills the push process. Usually, coverage drops happen simply because a developer writes a new module and forgets to draft the accompanying tests. Instead of throwing an error, it connects to an AI via OpenRouter, writing the missing test on the fly. Without an API key, a mechanical fallback system slides in, generating template-based tests to bridge the gap. The checkpoint actively writes the solutions required to pass its own quality thresholds, saving you from breaking your workflow to backfill missing requirements. Once the code clears these technical hurdles, the tool compiles a comprehensive markdown report directly into a local folder, logging every scan result and coverage metric. Only then does the script return an exit code 0, the final system clearance that permits your files to travel over the network and merge into the remote repository. If the push was blocked because of a sensitive file, like a .env or .pem key, the Guardian takes one final step. It automatically appends that specific file to your .gitignore, ensuring you don't accidentally stage it again. When you press enter and the push successfully executes, you aren't guessing if the code is safe. You have a documented mathematical check confirming both your privacy and your software stability. This entire repository, the core scanning logic, the test generation, and the documentation, shares a single origin point. Prepush-Guardian was built without a human engineer. Every logic gate and rule was planned, tested, and verified autonomously by an AI agent named Neo. The software represents a machine analyzing common human development habits and constructing a digital bouncer to filter out the mistakes we make when coding at high speed. As AI-driven development allows codebases to grow at the speed of these accelerating gears, manual oversight faces a massive scaling problem. Automated pre-flight safety nets provide the necessary local friction to ensure that speed does not come at the cost of security.